So this is the new drive pulley for the lathe. It is aluminium, and it came with a Morse taper on the inner bore. So we've had to machine a Morse taper and then a little step boss so that it can mount on the 3/4 inch shaft. I'll stop it and then show you the bits. So here's the boss. It has a 3/4 inch ID, and then I'm going to part it off with a step here, and this is Morse taper essentially. So I've machined it. I've actually left it a little bit rough in the machining because we are going to press the pulley on. So I'll just heat the pulley up and then tap the boss in and hope the interference fit will let it lock on. So that's the theory. Heating up the pulley to press the bearing. Need to go to about 110 C. I'll come back when it's up. Oh. There we go, it should be. Okay, so I've pressed it in and it's down to, it was 110 when I tapped it in. I just dropped it in and gave it a little tap, and you can see it's probably closed in about 1 mil, so that's not going to come out in a hurry. I'll let it cool down and then we can carry on from there. Taking a 40 thou cut. This is machining the Arbor for gear cutting. Going to add the Morse taper while I've got the compound set on the Morse taper angle. So I'll make the shaft up today. That's quite an impressive finish for a 40 thou cut. Look at the swarf. Nasty sharp ones. So there's the Morse taper end of the Arbor. So 12 mil tap in the end so that I can put a drawbar in and pull it in. So I'll spin it around and start machining the other side. I don't know if this is going to make any difference, but I've marked the Arbor to line up with the end of this thread so that it's a consistent point for putting it back in the same way around. I'll machine it up and give it a test in different positions, but it's just, I don't know, we'll give it a whirl. So here's the continuation of getting the change gears fixed on the Logan Lathe. If you recall, we have some dodgy O-ring drive running at the moment. I'll insert a bit of a picture here. This should be the spindle gear driving the 2 reverse gears. So this lever will change from that, driven off that gear or driven off this gear, which gives you your forward or your reverse off the spindle, and then you can adjust or change out these change gears. I will 3D print them. This is all that it came with. So in the process of having to get a replacement 30-tooth spindle gear, of which they're not unobtainium, but just ludicrously priced, I've got the material and I will cut them. But in the process, I need to be able to drive the lathe to get to that process. So I've printed some plastic gears, and I have put in a metric 30-tooth module gear. It's going to chew out the plastic, but it will drive it long enough for us to do the machining to get the 30-tooth spindle gear made, and then from there on it's all plain sailing. Because the module metric 30-tooth spindle gear is slightly smaller, I've made an offset pin for the reverse gears, and then pressed in a steel bush into a plastic gear, and that's basically going to run mesh in the rear. I'll put some light in there and show you. Here's the change gears. That is a metric 30-tooth gear that I machined previously. It's only there to run for long enough for me to be able to machine the replacement gear, and then we're running a combination of plastic and steel original gears. That's the reverse gear, so I'll insert that with the cam and then get back to you. So there we go. We have gears running. This needs to be tidied up. There's a few spaces need to be made, especially down here on this pulley. It seems to work its way out, but I'll get it running and we'll see how we go. Still haven't changed to the 3-phase motor yet. The pulley that I machined, which is in this video, is going there. There's the second reverse gear with the steel Preston bush and the offset cam, so that you can set the tension on the gears properly. And now we have fully functioning change gears. So now we're going to be able to start to cut some gears and cut some threads. So yeah, the first thing is going to be working out how to set up the metric conversion. This is the 100-127 tooth, and that has to go in there. So it's going to be interesting. I need to have a look at some photos and see how people do it. I don't know whether it'll fit in the cover. So I'm just testing the run out, and it's pretty good. So across, so 400mm, 20mm mild steel, so machined it down to 19.34, and it stays 19.34 for the first half, and then closer to the chuck it grows 19.35 and then 19.355. So I'll do some tests closer to the chuck, but pretty good without a steady, so that's good. Making a replacement latch for the change gear lever, having to machine the flats because it's broken, but no mill, so set it up in 3-jaw chuck and away we go. There we are, change gear latch fixed, or reverse latch neutral. Cool. So there's heaps of play in that cross feed. You can see it in the brass spacer, it just pops up and down. It just doesn't, it's moving all over the place. So I've machined up a steel insert with a step at the top so that it'll clamp everything nice and tight, and eliminate that. I'll fire it in. There we go. No play. It's not permanent. It's a temporary fix until I do a full rebuild on the whole compound and cross slide, but or carriage. But it takes a lot of play out, so that's a bonus. So here we have all the right spaces and all the right ratios and all of the gears meshing in the right alignment. .32 with a chewed up 32 there, going to a 39, and then on we go. So that's the change gears, and then up here we have the new pulley, and this is still running off the old single phase, but I'm slowly working my way along. And one of the cool things about this is that it's actually got fan blades in as spokes, so there's just very gentle airflow. In fact, there's a reasonable amount of air flowing through, and it's drawing it out of the machine, which is actually quite cool. That's just a bonus. It's the way that the pulley came. So I've obviously changed to a serpentine belt, so the rubber belt. So the 3 speeds there, so that equates to, on the RPM, so first gear 170 RPM, second gear 300 RPM, and third gear 530 RPM. So nice and happy with that. I mostly do bigger stuff, so that's all good. I could put a smaller pulley if I want to go faster, but then I'll also have a lot more speed with the 3-phase variable speed controller. So this is actually quite nice based on the single phase motor. That's going to pretty much be it for this video, and then I'll get on to probably some gear work.
Please add your thoughts and comments, like and subscribe. Let's grow this channel.